Did you know that landing on Venus is possible without a parachute or even a rocket engine? This surprising fact was discovered by the Soviet Union 5 decades ago through a process of trial and error that ultimately unveiled the truth about one of the most intriguing locations in our solar system. Here's what the Soviets encountered when they landed on Venus and why they never returned. Venera is the Russian word for Venus, and also the name of a series of 16 missions designed to study and map Earth's closest planetary neighbor. Spanning from 1961 to 1985, the Venera project consisted of space probes and satellites sent to Venus to gather valuable data. While these missions were primarily conducted in the name of science, they also carried political significance, serving as one of the USSR's bold strategies to assert dominance during the space race. Although Mars receives the most attention in the 21st century, Venus was actually a major focus of planetary exploration in the past. The reason? Unlike Mars, whose surface can be observed using powerful telescopes from Earth, Venus has long remained an enigma due to its thick, impenetrable cloud cover. This mystery led to various speculations. If Venus had clouds, it meant it had a dense atmosphere, possibly even supporting life. Some hypothesized that Venus could be a tropical world covered in lush rainforests, home to strange extraterrestrial creatures. However, this idea, though more plausible than the notion of canals on Mars, was not widely accepted by the scientific community. Famed astronomer Carl Sagan had already proposed a different theory. Venus's unbroken cloud layer was a sign of a runaway greenhouse effect, making the planet's surface a scorching inferno. The only way to confirm this hypothesis was to investigate up close. As in many early milestones of the space race, the Soviet Union was the first to attempt a mission to Venus. In 1961, they launched 2 probes, Venera 1 and Venera 2. Given the high failure rate of space missions at the time, it was common practice to send probes in pairs. The Soviet engineers, with limited computational technology, relied on a basic onboard guidance system, attached a rocket engine to the probe, and launched it atop an R-7 ballistic missile. Then, they waited for the results. While both probes managed to fly within 100,000 kilometers of Venus, they suffered total system failures before reaching their destination, returning no useful data. However, in 1962, the United States achieved success where the Soviets had failed. The Mariner 2 probe passed within 35,000 kilometers of Venus and conducted the first close-up study of another planet. Its 42-minute scan confirmed Sagan's predictions. Venus's surface was extraordinarily hot, with temperatures reaching up to 237 degrees, 459 degrees. The probe also detected a thick cloud layer extending from 56 to 80 kilometers above the surface. Based on this data, NASA concluded that Venus was an inhospitable environment for both humans and machines, shifting its focus instead to the Moon and Mars. But the Soviets remained unconvinced. Determined to push forward, they developed the next generation of Venera probes. By 1966, they had designed larger, more robust spacecraft, Venera 3 and Venera 4. Weighing over 900 kilograms, 2,000 pounds, these probes were equipped with advanced instruments such as barometers, radar altimeters, gas analyzers, and thermometers. The plan was for the descent module to parachute through Venus's atmosphere and transmit data on temperature, pressure, and atmospheric composition. However, things didn't go exactly as expected. Venera 3, despite suffering a system failure, successfully reached Venus and became the first human-made object to crash onto another planet. The Soviet Union thus achieved a historic milestone, having already been the first to impact the Moon and later Mars. Venera 4, launched in 1967, was more successful. It deployed its parachutes and began its descent through Venus's atmosphere, making it the first probe to take in situ measurements of another planet's atmosphere. At high altitudes, Venus's conditions appeared surprisingly Earth-like, warm, with manageable pressure. But as the probe descended, temperatures and atmospheric pressure increased dramatically. After 90 minutes, communication ceased, likely because the probe was crushed under the immense pressure, comparable to being 1 kilometer underwater. The Soviets realized that landing on Venus was like plunging into an ocean of thick, crushing air. With this revelation, they suspected that future probes would face similar fates, but they launched Venera 5 and 6 anyway in 1969. Unsurprisingly, these missions recorded only brief data before succumbing to Venus's extreme conditions. Meanwhile, NASA's Mariner 5 mission provided additional confirmation of Venus's hostility, prompting the Soviets to rethink their strategy. Determined as ever, the Soviets engineered even sturdier probes for Venera 7 and 8. They reinforced the descent module with a thick titanium sphere to withstand the heat and pressure. They also devised an innovative parachute system designed to delay deployment at lower altitudes, minimizing exposure to extreme temperatures. Despite these modifications, Venera 7's parachute failed upon descent in 1970, causing the probe to plummet to the surface at a speed of 61 km/h, 38 mph. Surprisingly, despite sustaining damage, the lander transmitted data confirming that Venus's surface temperature exceeded 475 degrees, 900 degrees, hot enough to melt lead. Venera 8, launched in 1972, improved on its predecessor's design and successfully transmitted data for nearly an hour before succumbing to Venus's hostile environment. By now, the Soviets had a clearer picture of Venus. Temperatures of 900 degrees, 475 degrees. Atmospheric pressure 92 times that of Earth, equivalent to deep sea pressure, and an atmosphere filled with sulfuric acid. Yet, instead of giving up, they pressed forward. In 1975, Venera 9 was the first mission to capture photographs of Venus's surface. By leveraging Venus's dense atmosphere, engineers designed the probe to land without a parachute. Instead, an aerobrake system helped slow the descent, allowing the probe to free fall from 47 kilometers above the surface and land safely. The first image, taken in black and white, showed a barren landscape of jagged rocks. Days later, Venera 10 sent back another image, revealing a flatter, smoother surface. Subsequent missions, such as Venera 11 and 12, faced technical difficulties with their cameras but still contributed valuable data. Then came Venera 13, the first mission to capture a color photograph of Venus in 1981. The image depicted a desolate, rocky terrain, enhancing our understanding of the planet's alien environment. The probe also carried a drill to analyze surface samples, revealing that Venus's surface was composed of volcanic rock similar to solidified ash. Additionally, Venera 13 featured a microphone, allowing scientists to capture the eerie sounds of Venus. Mostly wind and mechanical noises from the probe itself, but unsettling nonetheless. Venera 14, launched shortly after, confirmed these findings, identifying basaltic rock formations similar to those found on Earth's ocean floor. And that was it, the last human-made object to touch the surface of Venus. Despite remarkable achievements, the Venera program ended as the Soviet Union collapsed in the early 1990s. Priorities shifted, and interest in Venus waned. Additionally, as technology advanced, it became more delicate. While Soviet engineering favored robust, heavy-duty designs, modern electronics, designed for efficiency, struggled to withstand such extreme environments. Today, space agencies focus primarily on Mars, but the lessons of Venera remain invaluable. As we push the boundaries of space exploration, understanding the past may be the key to shaping the future.